Zeal Education Society, redefining excellence.
Hello friends, my name is Chinmay Deshpande. I am from Department of Electrical Engineering. In this video lecture, we are going to discuss about power stages in three-phase induction motor. Now already we know that to the stator winding of a three-phase induction motor, always we give a three-phase AC supply. So therefore, let us consider that PI is nothing but the electrical power input which is given to the stator. Now, but obvious, whatever power which will be given to the stator winding, as it is a metal, so therefore some amount of a power will be get lost in the form of heat. So fraction of a power loss is there at a stator also. Now, there are two kinds of losses at the stator. First one will be core loss, that is stator iron loss, and second one is nothing but a stator copper loss. Now, these two losses are in the form of heat, but obvious. This stator iron loss, which may include AD and hysteresis losses, both will depend on the supply frequency and whatever flux density in the iron core. Basically, practically it is a constant. Let's have a look for another power. Let PG is nothing but a gap power, G is nothing but a gap, P is the power, or it is also called as rotor input power, which will be through a magnetic flux. Now as we know that as the rotor rotates, we get some mechanical power. So let that mechanical power will be denoted as a PMD, that is mechanical power developed, which handles actual mechanical load. Now as there is a current and EMF will be generated on the rotor, so therefore there is the existence of electrical power at the rotor also. So let's have a look for the power stages in a three-phase induction motor. Here, the rotor electrical power gets wasted in the form of rotor copper loss and in the term of heat. So therefore, we represent the power stages in a three-phase induction motor as. So here you will observe PI is nothing but input power which is given to the stator, and PSH is nothing but a shaft power to which the load is connected, or it is also called as output power. Now to the stator there will be one loss. That loss is called as stator copper loss plus stator core, that is iron loss. So when we remove these losses, then whatever power here we will get is nothing but a gap power. So this gap power is also called as a rotor input power. So therefore now to the rotor there will be a loss, and that will be a rotor copper loss, that is WCU. So when we remove these component of a loss power, then whatever power we will get is nothing but a mechanical power which is developed. Now that mechanical power is basically given to the shaft, or it is given to the load, and to the shaft also there will be losses. First one will be friction or the windage loss, which is also called as a rotational loss, and whatever component of the power which is left is called as a shaft power or PSH. So from this, here already we discussed that PI is the input power, PG is the gap power, air gap power or rotor input power. Then after that PMD is the mechanical power which is developed, and PSH is the shaft power of the output. Now from this what we can write? We can write this PI will be equal to this PG plus stator copper losses and core losses. Again, that's why here purposefully I have kept here equal to sign. Then second relation you will get as PG equal to rotor copper loss WCU plus PMD, that is mechanical power developed, and third is nothing but PSH. I can write here PS or PMD. Yes, PMD will be equal to PSH plus friction and windage losses, which is also called as rotational losses. So keep in mind, this is very important, and based on that the problems will be asked in the examinations. Now remember that for the stator there are two losses. First one will be stator core loss and second one will be a copper loss. But if you observe in case of a rotor, we discussed that there is only one loss, that is a copper loss. Here the iron losses are negligible. Now you will ask me question, sir, why iron losses are negligible at rotor? So the answer for this is, we know that what is the frequency of a rotor current. It is denoted by F2 or F dash. So rotor has its own frequency which is F2, and it has a relationship with your frequency, that is supply frequency. So F dash or F2 will be equal to S into F1. Now this rotor frequency whatever we have, it is very less compared to that of a supply frequency. Now as eddy current and hysteresis losses are frequency dependent, so therefore here we consider iron loss is negligible in case of a rotor. So this is what is the power stages in a three-phase induction motor. Now how to find out efficiency? But obvious, simple formula for efficiency, output upon input. So here output power is nothing but PSH, input power is PI, so I can write efficiency of the motor equal to PSH upon PI into 100. Now these are the formulas, PG equal to PMD plus rotor copper loss. So from that I can write PG minus rotor copper loss equal to PMD. Now this this mechanical power developed, that is PMD, which gives rise to a torque which is called as a gross torque. Out of this gross torque, some will be lost in the form of windage and friction losses, whereas other will be appear as a useful torque or the torque which will be required for some mechanical action, which is denoted by TSH. So this is about power stages in a three-phase induction motor. Thank you.
Zeal Education Society, redefining excellence.